Our next speaker, whose name is Sambath Logakrishnan, and Sambath comes from web stack land with more than a decade of experience, well, also mistakes and wisdom that comes with experience. He's curious about bleeding edge technologies and raw poetry, and his mission is to make business user experience to the point and easy to use so that there's no manual needed. He loves to talk about yoga, jazz, food, and non-traditional movies. And the latest thing with Sambath is that he's become responsible for a new life. And the new life, I'm not sure if Andreas is still in the room, but the new life is a German Shepherd. And Sambath promises that he will raise this German Shepherd to be a very responsible citizen. But this time, Sambath is going to talk about why you should start to think about compiling your code into WebAssembly. A warm welcome, please, Sambath Logakrishnan.
Good afternoon, everybody. Can you hear me? Yep, you can hear me. My name is Sambath Logakrishnan, and as Raphael mentioned, I'm coming from WebStack land. Before I get into the talk, I have some questions for you. How many of you guys here are C, or C++, or RISC developers? Raise your hand. Oh, a lot. How many of you are JavaScript or web developers? Quite a few. That's good. How many of you are here module developers? You own your own modules. Okay, that's good. Today we're going to talk about WebAssembly, the new standard that has been around for the last 5 years, and right now it's getting a lot of momentum. And I'm going to give you an I'm going to give you an informative talk about WebAssembly today. Let's begin. Right now, 2015 and 14, the standard came up. WebAssembly standard came up from Mozilla. As a more like an coin to alternate something for JavaScript. We know all that JavaScript sucks. There is no literal way to put it another way because it's a dynamical type language and it comes with chaos. And I'm a JavaScript developer for more than a decade, and I know it for sure. And I always also looking for an opportunity to learn something to adapt to the web, but there is nothing there, only JavaScript. If you want to code something in web browser, you need to be asked to be JavaScript. But luckily, this came. This standard came as an idea. Initially, it was more like a speculative. This won't be another deal because there are a lot of initiative happened and everything gone eaten up by JavaScript ECMA standards. But this becoming not becoming a standard. It becoming from idea to an actually a thing. That is more like a standard that is being implemented by all the major browser right now in the web. From Chrome to Firefox, Safari promised, IE became Chromium, so almost all the browsers right now supports WebAssembly, and already the MVP standard already there in the browser. Today we're going to talk about from the point of history, why the WebAssembly is needed. From the point of history, then we're going to talk about the problems we faced in the history and how the WebAssembly is going to solve it. And also we take a look at the future, what's hold in the future right now, and how WebAssembly can also solve that problem too. And we're going to take some look at some features that's going to come and also already available in the WebAssembly and the current state of the WebAssembly in the companies, how it is being used right now. Let's begin from the history. Before that, you know that I'm a JavaScript developer, and I generally wrote business logic. I didn't care about system programming language like C or C++. I don't even care about system calls. I always keep myself to business logic. That's all my side. I don't want to go into the system call world because I have no idea what it is. But I have to enter right now to it. Let's go back to the history, 90s. This is the time I started to see the computer in my life, and I able to understand what it is. First program I wrote was in BASIC in Microsoft. Some addition program. After the addition, I lost myself. This is my world. And during the time, something came up. Object-oriented programming language came up, something called Java. You heard about it, right? Java, it became a big deal in 90s. It becomes with something called virtual machine. Even though the concept was available from 1960, but they made the virtual machine as a more like an shiny new toy that everybody likes to have it, and came up with this idea of bytecode. That means you can build once, you can run anywhere. This is an idea that became more like popular because of its box runtime and also because of its marketing. Because Java spent millions and millions of money on marketing the Java. It almost spent about $250 million from from 90s decades. It spent almost $250 million on marketing alone on Java. That's why it became the world popular tool language right now. Otherwise, it's not that much popular. It's because of that marketing was involved. With the Java, some problems came. Java was a successful language in object-oriented programming language, especially in the web world. It solved a lot of problems. It opened web development to the people for object-oriented programming, so it's very simple to develop the language and deploy everywhere and deploy everywhere in server. But the same idea didn't work out in the browser. Build once and run everywhere. You know that the applet, Java applet, how many people write Java applets? How was the experience? It's terrible, right? It always comes with a lot of quirks and things. It works in IE, it won't work in Firefox. That time it was called Netscape, its name was. Always there was a difference was there. After that, everybody removed it. Applet requires a lot of magics in the browser. You need to install browser. Your operating system has to be some level up. Microsoft has to be some level up to make it work. It has to have the Java runtime, and security is a big hole. You can do a lot of attacks on the applets. That it's more like you're basically opening your system to the entire world and take it me kind of approach. So, but in the browser world, it didn't pick it up because of the security issues, and also for development cost, it's very high. But the idea of bytecode, or the P code, because the general name of the bytecode is P code, gave a boost that you can able to give that portability. After the bytecode, Android came, and with the portability that you can able to do it. So this portability becoming more like a necessity for a web stack developer or for any developer right now. After that, it also frees the application developer from knowing the system architecture to make a call to a file system or a socket or anything. I just need to make a call to Java. I don't know how the Java is going to do it in JVM level. It do the magic. And I'm opening a file, I'm sending a message in the socket. So, but it gives me that a gap to know, doesn't not know about the system architecture to program something in application level. At the same time, in 1995, there are two things happened. Browsers came up, interactive browsers started coming up. One is IE, one is Netscape. How many people still uses Netscape? I have a machine in my home that is 1995 Windows and still have Netscape. I use that for some game purposes. Because I have some score, I don't want to erase it, so just keep it. That's why I have a machine and still make it running it. I still have it in my home right now. I actually exported from, imported from India with a huge duty price because this is some hardware bullshit. Let's talk about the JavaScript. There was a duel going between the Microsoft and Netscape, because who want to take over this new market, web. So they both are coming with two different languages. One is JavaScript from the Netscape, another one is called VBScript from Microsoft. How many people you have heard about the word VBScript? That's cool. I also programmed a little bit on the VBScript, and I hated myself. It was more like a Visual Basic on became a script kind of stuff, so I didn't like it. Luckily, Microsoft itself killed it and moved it to JavaScript. JavaScript was a success, and it's a huge success right now. It's one of the highly contributed language in the world, and in GitHub it is the #1 all-time champion. Almost 12 million active developers are there, and every year almost 2 million developers are getting added into JavaScript. It's more like we want to become a developer. Right now, the entry point is becoming a JavaScript developer. That's the how it looks like in the general world. Let's take a look into the history of JavaScript. How JavaScript came into the name JavaScript. During the time Microsoft came with VBScript, Netscape wanted something similar, but the Netscape had a partnership with Java during the time, Sun Microsystems, and the author of the Netscape wanted a Lisp-oriented programming language for the as a scripting language, not as an object-oriented programming. But due to the pressures from the from the Sun Microsystem, they have to go to object-oriented programming language and also put the word Java in front of it for marketing purposes. They thought somehow Java will take over the JavaScript, but it didn't happen, luckily. The first name was Mocha. It's not JavaScript. The initial name was Mocha, and it was Lisp-oriented, but it was deprecated before product got launched. And this language, JavaScript, initially meant for basic pixel manipulation and just some event handling. It's not meant for complex calculation or anything. It's just meant for single thread, not more than one thread. Enough. Just you take a thread and change something in the UI and give it to the user. That's all JavaScript is meant for. But in 2000, there was something change happened. Desktop computers will get multi-cores. I have a vivid memory about buying my Intel Core Studio processor first time. And I was trying to overclock it with 2 cores, how to break the system. During the time, there was no way to use that multi-core in the browser world because it's single-threaded. I cannot able to use it. Luckily, in 2009, HTML5 spec came with a concept called web workers. Still, this concept is not being overall being used. This is a concept of a web worker is nothing but you're spanning multiple threads of JavaScript instances. And you can communicate through the post messages, or you can use shared array buffer to communicate it, to make use of this course. So right now, most browsers stopped supporting shared array buffers because of security reasons. You know, this Spectre bug and Meltdown bug made that all the browsers to stop using this shared array buffer. Right now, in Firefox, it's been stopped. It means halted. The feature is there, but it's been blocked. Only right now in Chrome is been enabled back. And you know, JavaScript comes with a lot of precision problems, especially with numbers. Exponents, it always comes with, if you do some kind of complex mathematical formula applied on JavaScript, it always comes with wrong results because JavaScript is designed in such a way. It is not meant for complex calculation, but people have started using it. Node.js. Generally, Node.js is need to be used for code operations. Pull something from the database, put something in the database, that's all. Do not write business logic on it. But people started writing on business logic on it, and it became a chaos. After that, Node.js has to implement a shimming layer with the C language so that it can able to do all this complex calculation on that layer and bring that information to here. It's kind of more like in a crazy world. But what to do? But this is the only language for JavaScript for the browser during the time. Have you heard about this Dart VM? Anybody? It was one of the, in 2013, there was some initiative come from Google that they fed up with JavaScript. They said, enough. Let's do something new. So they created a new VM within the browser, in the Chrome. It was there available for a few years. It's called Dart VM. It comes with its own language, Dart. It's a typed language. It's more like a mix of JavaScript and Java, again. But it has statically typed, and it is much more senior than the JavaScript. But unfortunately, this language didn't get any momentum, even inside the Google. So Google has to drop this entire VM concept and get rid of it. Right now, it's not available. But the Dart VM becoming another feature itself. Right now, it's being used in OSs. That's a different story. Let's take a look a little bit about the JavaScript chaos, especially when you are opening a web browser and you type some URL. A JavaScript comes in. It comes in with a content type, like application slash JavaScript. Once a content type is like this, you're telling the browser it's a JavaScript. So begin the parsing. First, it has to be parsed, because JavaScript is text format, so it has to be passed from string to tokenized, then validated, again retokenized. This time it is AST tokens, then compiled, then we execute. Then we are doing right now in the most browsers like SpiderMonkey and V8, they have something called runtime stats. This is the first machine learning implementation, I would say, in 2009, called just-in compiler. That is more like how many times in a script function getting executed. Based on it, it is being optimized, re-optimized, and code is getting flexible for that. This, in my view, this is the first machine learning implementation in the wild, in the browser, been there. And it's going to optimize it again, compile back, and you know the whole story. And there is GC. Right now, in V8 and in SpiderMonkey, if you see a jankness, most of the jankness coming from this from this garbage collection, because we are creating too many DOM elements and objects, and get too much garbage collection is happening. So it literally can stop your mobile browser from working. It can freeze it. That much problem is there. You can see that steps. There are about 5 steps need to be happen to make one thing work. It's not like download, execute. No. It needs a lot of magic before it has to be happen. Let's jump into the future right now. In the future, we will have a lot of devices, and we will have a lot of platforms to code. For example, right now we have CPUs, GPUs getting popular in the cloud, and FPGA also getting popular in the cloud. Right now, Microsoft owning about 100,000 cores of FPGAs there in the Microsoft Azure. And we need to, and FPGA coming into smartwatches too right now, and it's more like it's going everywhere and everything. So like we need to have devices that gonna be, CPU can be in the AR, VR, also in a GPU can also be there. It also can be IoTs and clouds and phones, and everything is mixed up right now. And everything has one thing common. They're gonna run third-party code for sure. Because in the future is all about this. The code also becoming data. There is no install. That install step has to be gone out in the future. That's what I'm saying. And your code has to be data. That means you're going to run all third-party code in your devices. It can be your cloud, your IoTs, your smartwatches, your phones. You're going to trust a third-party cloud. I'm not trusting it, third-party clouds, third-party codes, because it always comes with some hooks or some security issues. There are too many categories of devices going to come, and kernel architecture also quite soon, because I can see that a lot of kernels being tossed, new words have been tossed, and the market share going to be held from big giants from Google, Microsoft to open source organization like Linux Foundations, also going to have their own hardware called Open RISC-V architecture, ISA system instruction set architecture, something. It's going to be look like this market share, especially in the hardware world. Right now, Intel is investing hugely on GPUs and FPGAs. They have Intel bought a company called Axion or Altron. I forgot the name of the company. It's the biggest FPGA manufacturer, and they swallowed it. And Microsoft going into the FPGA, and they're seeing that FPGA becoming a more like big deal. Google know that they're building their own hardware side now, TPUs. NVIDIA coming with an even more faster GPU design, and AMD's on their own track, ARM on their going fast phase, and Open RISC-V is on Linux Foundation getting a lot of momentum, and we have open power architecture from IBM and Intel. It's more like a mixed match. And also the last thing, the China and India making their own processors right now. They wanted to have their own ISAs and their own systems. They don't want to rely on Intel or AMD anymore. It's $1 billion. It's more like 2 billion people going to use separate something different, new architecture that nobody ever have no idea about it right now. So there are a lot of architectures going to be evolved up. So maybe in Europe there will be new architecture. Who knows? Maybe because it's coming from Asia, that's going to can catch up the same fire in Russia too soon. Maybe. So it's going for system developers. It's going to be a big hurdle right now because you need to support all this kind of new processors and stuff, and the kernels and everything, and it's going to be chaos. But system architecture has to do it because it's system, but not for the application developers, because software developers should not worry about these things. But it's not so easy for if you want to write in high-level language. For example, I'm going to write in a language called H, and I want to support all this architecture. It's not going to be very easy for my life. So I need to know all these things. I need to focus for China separately. I need to focus for India separately. I need to focus for Intel and everything. And it's going to, my life will be in chaos. So in my view, that it's in the future going to be a tough job for anybody to maintain this kind of things. And the approach of C cannot be scaled. This is more like write your own libraries and everything for that to make it happen. It's not going to be scaled for everything, for a high-level language. And high-level, at the same time, domain language has to be invented. New domain language has to be invented, but it should not be targeted to the native level. It can be somewhere between below up in the virtual level. It boils down to the same thing, virtual machine. But this virtual machine has to have some kind of criteria. It has to be portable and sandboxed for sure, and also to be high performant. Has to be there. This need to be there for high level language to run in this virtual machine. And this, yes, new virtual machine. This virtual machine has to be not exclusive, but has to be inclusive. You know, JVM is an exclusive engine because it cannot support other languages or Haskell or something. It only supports the special set of instruction sets. But there is a new initiative from Oracle called Gravel, but I'm not sure how it's going to pick it up. But we need something, an inclusive VM that has to support Haskell to Java. This VM has to fulfill some mandatories like sandboxed. Sandboxed in sense, it has to be locked out from the sockets and file system completely away. And it has to have a memory, that bound linear memory, that we should not access to the system memory. It has to be bound so that it doesn't know the actual, more like fake addresses for its own system. So it won't go and corrupt the other memory that is used by the other programs. So it has to be sandboxed and performant. This virtual assembly has to be run much faster, really faster, not like JVM, because JVM bytecode is slow, for sure. And it has to be portable, portable bytecode, because as I mentioned, your code has to be data. So it has to be sent to the network much faster as possible. So it has to be binary and also to be as thin as possible. And it has to be an easy implementation. For example, an easy implementation can be a stack machine than a virtual and a register-based machine, because stack-based machine is much more easy to implement, and there is no much complex logic involved. Even a CS major student able to write in a stack machine easily, and it has to be interrupt. It has to interrupt with the host easily. These are the criteria. Has to be this new VM has to be followed. This bytecode has to give these opportunities. And this right now the WebAssembly MVP spec specification actually satisfies all those criteria. That's good. And they've proven that in the JS engine, it's faster, really faster. It's how much faster? Is 4 to 3 times faster than a JavaScript. After JavaScript optimized, that's good. And this provides linear memory, tables, global instances, modules, so that you can do all kind of magic with it. And it comes with a limited data type. It has only 4 data types: I32, I64, F32, and F64. That's all. There is no other data type like strings or lists or anything, complex data types. It's just very limited system. But there is a big problem right now here, because this MVP spec is meant for a computational runtime. This computational runtime is boxed, completely boxed. It doesn't have access to any IOs, any systems, anything. It's more like a jail system. You are giving a source code and data to it. It runs and gives data back to you. That's all. It cannot have. He had no idea where it is running or anything. It cannot access the file system or IO anything. So it's a problem. because we want to support, give an I/O system to these WebAssembly. So it will be much more flexible and easy for other high-level language to use it in the from smartwatches to your laptops to your mobile phone and whatever the AR devices are, or any device that's going to come. But lately, after WebAssembly came, MVP feature came, there are some people started to hack around this WebAssembly runtime. There are some blockchain companies like Ethereum created their own, they forked the WebAssembly code runtime, and they created their own I/O system to have this WebAssembly to run it with I/Os and file system access. But it was not standard. It is more like a chaotic implementation just to see that it works in the market or not. Same time, WebAssembly community see that it is more like an opportunity than more like a problem. So they think this is the best time to go beyond the W3 console to make it more a big standard than only for specific to web. Here comes the new standard called WASI, WebAssembly System Interface. There is right now WebAssembly core as a community has support from all the browsers. But there is a new community, and also there is new supporters also coming in right now. Like Fastly, Cloudflare, Dignify, and a few other modes are getting added. Right now, Red Hat been added, Intel been added last week. I'm going to talk about later. They're going to, instead of mimicking this JavaScript glue code to talk with these IOs like file system or sockets, they want to standardize this. They want to hammer out this interface system calls to a conceptual OS. To a conceptual OS than a real OS. Let's go and talk about a little bit later. This about why this has to be conceptual OS than real targets. Before that, let's talk about a little bit of problem of applications. Generally, an application without an operating system can crash each other based on two things. We can, two applications can kill each other based on fighting for resource. Or another thing is another application go and listen to another application's data. Data leakage also be there. So there has to be some kind of protection has to be there to make this these two things not to happen: crash and data leak. The early operating system like of Linux or Windows solve this problem using this ring protection in the OS. It's like we have an app like calendar that I just want to access in a folder in your system. It asks the kernel, and the kernel checks that this user has this access to that file or not. Based on it, it gives the system, it gives the access. Generally, the access is based on user group. But last 10 years, we have new changes coming up that we don't have multiple user in one system. We have one user, but this user runs mostly third-party codes right now. Example, Docker. We are just running in a single user. Mostly Docker has single user and runs a third-party, usually generally not third-party code there. Third-party code, more like most of the modules, where the security becomes very important aspect. Because we are running node modules right now, about 10 to 20% of node modules are compromised because it's been the developers been outdated and it has been bought by some Russian hacker or Chinese hacker, and they put some Bitcoin mining code inside it, and they found out that there are few modules if compromised. 90% of the npm repository will be compromised because of the dependency chain. So there are big problem is there. Right now, if you are having if in that case, for example, you have an app that has a node module that has that module is compromised right now. It's more like it's going to sneak in and get your Bitcoin wallet. For example, you know how many people are using Spotify app? Spotify. There was a bug last year in the Electron app in the notification that notification module was compromised, and this notification module has a C module inside it. It actually goes and finds if there is any Bitcoin wallet is there or not. If there, it steals it. It lived there in the Spotify for 4 days, and many people lost their wallets. So it's actually a real thing that's happening right now in the real world. So it has to be sandboxed. So we need to block this kind of risky app from compromising your machines. And how your application talks to your kernel, generally using runtime. Before making research to this talk, I have an assumption that a C language directly talks to it overrides the kernel. That was my assumption, general assumption. I have no idea. C comes with a runtime. Even C++ Rust has their own runtimes. And even WebAssembly has its own runtimes, even though the stack machine is there. And generally, the stack machine will implement it on a C or C++ implementation. So there will be a runtime. The only thing that has no runtime is assembly itself, assembly code itself. Other thing, everything has its own runtime. You know that Node is a fat system. It has JS engine. After that, there is a runtime. So there is a runtime after within runtime. It's more like Inception. Within it, runtime within it, runtime. So it's a kind of a chaos there. But at the same time, we have to give that flexibility to module developers that they should not worry about worry about targets to write the code for their modules. They have, for example, a module developer for a physics engine should not worry about these targets. They have to be more flexible. This all should be more like there has to be in a closed doors, this kind of chaos. That's why it has to be Conceptual OS. And it has to be supports security and portability has to be first class requirement. It's not compromisable anymore. It has to be there in this new WASI specification. For instance, we are running on a WASI runtime within your node or in the Rust. It has to be sandboxed. For example, an open file in the node has to map to an WASI open conceptual API. And because of conceptual API, after that, the WASI implementation of your target, for example, for Linux 64-bit, has to translate this WASI file open to this file open in the libc file open system. So it has to be targeted on the WASI level. And right now, there is one more layer of security is being added to the WASI. Because the user level security is not anymore enough. We need to give an app that security only what it is required. For example, I have an app that only requires EC2 host, nothing else. So I can have able to give that to this WASI runtime that only accesses EC2 host, nothing else. So everything other directories have been blocked. So any risky app won't be compromised. Even though you're running a risky app, it has a malicious code inside it. For example, I want a password, but it has no access because it has been blocked inside the WASI runtime. There is no access to it. So your access been blocked. At the same time, whatever the access you are giving, it is given to all its dependency modules too. So it is more like chained kind of effect. So it is easier for implementing some level of security if user wants it. If user gives no security, that means it's running like a system user level. That's not good. But it at least give an option for an user to give a control that you can able to control what file can be accessed by this program. What? Okay. And this is the current status of the WASI spec module right now. WASI, you wanted to have this spec has to be modularized so that it can be implemented as fast as possible. Right now, they had some specs being more like formatted or more like came into shape, like socket file systems, unclock, and random generation. And there are a lot of specs discussion is going on, especially for VPNs, for the 3D graphics sensors and things. You can take a look into the community right now. The community is very open, and they are accepting a lot of inputs from the users. They are actually, if you can have time, you can take a look into the GitHub page and you can comment about it if you want to have some kind of requirement or you found some kind of problems in it. Let's take a little bit about the WebAssembly right now. After the MVP, what happened? Threads are being introduced in WebAssembly right now. That's a good thing right now. In the MVP, there is no thread. It has to be run in this single thread. So whenever you run a WebAssembly in your main thread, actually your system gets freeze. For instance, there was a guy who implemented a quick game in WebAssembly and ported to the browser. But when it downloads to the browser, entire system froze because it's a single-threaded environment. It gets frozen. So it was a problem. Then WebAssembly team introduced a new spec for threads. This thread is a little bit different from the general thread. It is a host spawn thread. That means host has control over the number of threads has to be being spawned for this WebAssembly. That means not one WebAssembly module cannot create n number of threads by itself because it's maybe in a security problem or a performance problem because the one module has demanded 100 threads, but system cannot provide it. So it has to be spawned from host level. Right now in the browser, it is being tied to web workers. So if you want to have threading environment, you need to go with the web worker aspect. So, but right now only it is being supported in Chrome. Because right now Chrome only supports this feature because of shared array buffer being opened in the Chrome. Soon in Firefox, because shared array buffer right now is being blocked because of these security issues. Once they got resolved, they will open it so that there will be more multi-threaded WebAssembly apps will be there in quite soon. And there is one more new thing came up with WebAssembly. It's called single instruction multiple data. It came right now only in Chrome right now, but behind the flag. But the results are very promising. This is very fast, really fast. General, take a look into the SIMD. You know, SIMD, right? It's more like you are going to do a bunch of operations together in one instruction. That's mostly SIMD. For example, you want to do a multiplication on an array of numbers. Generally, if you want to do it in a loop, you will going to create an instruction. First, load the number to the register, then multiply and store back into the memory. So we need to do it again and again for every time. But in the SIMD instruction, we can do it in more like in the batches. For example, 128-bit register, we can able to do it. We can load 4 numbers together and apply multiplication on it and store back 4 numbers back. So you are doing it much faster. This kind of application get faster. Especially it will be helpful, really helpful in the browser world. Especially comes to you're dealing with data like multimedia data or machine learning models, because most of the machine learning models are nothing but metrics, multidimensional metrics. So it will really helpful for the browser to pick up the speed and make the use of these cores much effectively. But why it is much more big deal right now, SIMD became? It's because SIMD is around from 1967, this SIMD, because right now, and also CPU supports from desktop from 2000, early 2000 itself. But the real game changer happened last March. This was in the ARM. Your mobile phones right now, most of your mobile phones architecture is ARM architecture. Either it's iPhone or Android based, or any Symbian based, or it's other Samsung based OS. Most of them are ARM based. Right now, ARM provided support for 128-bit bit vector registers, and they have a new extension for scalable vector extension. Version 2 is being implemented, and it is being adapted by the LLVM CClang and also by the GCC 10. So it is more like something that SIMD gonna be used in the mobile platform very effectively. That means your mobile phone browser can able to have machine learning models quite soon. That's why the SIMD becoming much more important in the WebAssembly world to make it run much more safer. Let's take a look at a simple program in the WebAssembly. In the C program in the SIMD instruction. just an array of multiple array. You are doing a multiple operation on an array. Same instruction to every element of an array. If you are doing an auto vector, if you take a look at if you compile into the WebAssembly code without a SIMD, it looks like this. It's a loop. First take an element from the array and from the store and multiply and load it to the register, multiply and store it back again to the memory. So it has to do it every time, for every element. So the number of operation has to be happened is more like size of element and multiply by 3 instructions been applied plus 1 because you need to load this multiplication number 10 one time to the register. Sorry. But in the auto vector with the SIMD enabled, the instruction look a little bit different. Right now in the loop, first load a 4 instruction, 4 element into the register, then apply multiplication on that and store back it again. So the number of operation got reduced almost by third of the instruction been reduced. So the instruction, if the number of instructions reduced for an operation, that means the performance time, the performance time get increased theoretically, and it does. For this operation, it's more like if you see the 10,000 element, you get more like 3 times higher the performance, and it's there for every level. It's not you get 3 times more performance on same CPU and single core, so it's good. And right now you can see that this right now with the WASI with WebAssembly, it looks very similar to Docker, LXC based system. Because Docker is nothing but an LXC manifestation, an Linux container. But if you see that Docker is really performant when you run on top of a virtual machine that is based on also on Linux. If it's based on a Mac OS or an Windows hypervisor, there is a performance degrade is there because there are a lot of bridges has to be filled up to make it work faster, but it's not that much performant. But the WASM can able to replace this problem. It can be an alternative to Docker itself in most of the cases. That means Docker does not go away, but it can replace most of the Docker's use cases. And Solomon, this guy, Solomon Hykes, is the original guy who created the Docker container in 2008 when the company called Docker Cloud. And he was tweeted about in the last March when the WASI spec came up. He told that in 2008, WASI was there. There is no need of Docker itself, because 90% of the use cases of Docker can be solved with this one, and it is more lightweight than a Docker. Maybe this is another solution for a Docker because it can be lightweight, much more lightweight. And the new thing came up right now, last week. The new thing is called Bytecode Alliance. This alliance is formed between Mozilla, Fastly, Intel, and Red Hat to make this WASI spec much more stable. From the hardware perspective, from the cloud perspective, to an operating OS perspective, they need to be standardized very good. So they formed a new alliance to make that happen. And you can take a look into the Mozilla's blog post. They explain detailedly why it is needed, why Mozilla can't able to do it by themselves, because they told that a lot of gaps need to be filled before the WASI spec has to be standardized. Let's take a look at a case study right now in the wild. You know the company called Fastly? How many people know a company called Fastly? I use Fastly. It's a serverless platform, cloud platform right now. It supports WebAssembly runtime as a serverless environment. Right now, they are creating a runtime for every HTTP request comes to the Fastly one. And it is much more faster than a V8 engine right now in serverless environment. How many times? In the order of 3 magnitude is faster, both in time and in memory. Let's take a metrics. This is startup time. Right now, the startup time for a WASI runtime on Fastly is 52 microseconds. It's much faster than a V8 engine. Right now, V8 engine takes about 5 milliseconds. This is in 52 microseconds. So it is more like these two are 2 worlds apart. So it's much faster, and it's much faster when it is going to use a shared or object. There is no need of new object initialization is not needed. It's much more faster. It's only 30 microseconds. And doing if you want to do memory swap within this runtime, it is in nanoseconds. So it is crazy fast. So the serverless computation, it can be this good runtime to run a high-level language. Like for example, I want to write a Java code, but runs much faster than in JVM. But how cool it is that? Same thing goes for Haskell or Python. But right now, what's the status right now in WebAssembly? Right now, there are questions like this. Because right now, currently, 50% of WebAssembly right now in browser are malicious, are used for Bitcoin mining or script injections. Right now, if you go to some random website that does a Bitcoin mining, is based on WebAssembly actually, and they're doing script injection. Generally, this has been used, but this number going to be gradually going to change once people take a look into the uses of it. Soon, there is a new spec is coming up in called WASM interface types. Why it is needed? Because as I mentioned that WebAssembly only supports 4 data types, only numbers. But the high-level languages has strings, string list, a lot of complex data types. It has to be supported. So they come up with a new layer custom section for WebAssembly called interface adapter. It has a logic how to convert this complex data type into number back and forth. What it gives us the benefit is that this. Right now, if I want in the browser, if I want to run a WebAssembly code between Rust and C modules, it has to goes through the JS back and forth because of trampoline jumps, because there is no connection between, because there is no communication, data type contract is there between the Rust and C++. So C or C or what or C++. But with interface types, we can able to create this kind of interface type, so that we can able to import a C module, WASM module into Rust code and compile into WASM code. So it will be much more friendlier. So right now I can able to write, in future I can able to write a Java code that can talk with can be imported to Rust code, can be imported into a C++ code. I can compile into WASM code to run it in a runtime. How cool it is that? So that in a dev team, everybody can choose their own languages, but they can deliver together. It is really good. In my view, it is a really good game changer. And what about high-level languages, the garbage collections? Because right now, there is new spec coming up in WASM for garbage collection. They are creating low-level API to use host GC to make use of it. For dynamical type, please get a type, because we need a type. Without type, we cannot able to port your example JavaScript or Python into WASM. That's why JavaScript, TypeScript, Microsoft coming with a new script called assembly script to get rid of this problem. And Python has to come up with something similar to make that happen. And when to use your WebAssembly runtime in your right now. You have necessity that you need to run third-party modules in your system. For example, you have a Python runtime, but it has to run third-party codes, and you are not sure about this code security. Then we can implement in a stack machine with WebAssembly, and you can run that code inside it. Much more safer, C++ code or C code, much more safer than without openly running in your system level. Or else you can stay native, because native is much more faster than WebAssembly. That's for sure. And this is not the end, because this spec is only get standardized, and adoption rate is very high in the browser world. And I can see that cloud computing systems like Cloudflare and Fastly is getting into it. I can see that AWS and also Google Cloud also take a peek into it. So it's maybe the future. I'm not sure, but it looks like that. And this is all from my side. Thank you.